Hello, class. Hello, everyone. Welcome to lesson 3 in our series, Statistics Made Easy. Today is about mean, it's about standard deviation, and about variance. In the last lesson, lesson 2, we scanned the data that we collected for our study. We classified the variables and did all of these other things that you have on this slide. Today, we are going to be calculating the mean, the standard deviation, and the variance for the data set that we collected. It's like climbing the tree of advanced statistics from the lower rungs of the ladder. That is, in doing mean, standard deviation, and variance, is like, look at this saying in my place. I'm Yoruba. Ti ibi pelebe mu oleje. This is ole. That's bean cake. And when you open this lid, when you want to start to eat it, you eat it from the small ones here, adhering to the lid before you eat the main thing. So we are coming from the lower rungs of the ladder of advanced statistics when we're teaching you mean, standard deviation, and variance. But have you ever wondered how all these mathematical symbols came about? Percentage, pi, infinity, square root, sigma. Well, wonder no more, because these have come about as a result of agreement among mathematicians. They come together as, for instance, International Congress of Mathematicians. Here, they will decide our fate. How? They will decide what symbols they will be using. They will decide, agree on the statistics, on the formula, and all of that. You can see that. You can see some of the earlier members of the International Congress of Mathematicians. So are you afraid that this course will be about all these scary formulae? Are you afraid of that? Fret no more, because this course is not about all those scary formula. Why? You are conducting research. You're very lucky. In 2020, you are conducting research in an era of advanced technology with very powerful software tools like IBM SPSS, like Strata. In class this morning for the meeting I had with you, David from DRC talked about some other software. There are very many software that we're lucky to have this in 2020. So let me give you a little bit of history. They are called with me to 1970 while I was at University of Ibadan. While we're finishing doing our project in 1973, and we used to use punch cards, and we write long codes and programs for data analysis to the computer center. And you have to tell the computer, because the computer doesn't know what t-test is, doesn't know what ANOVA is. So you have to, the formula and say, take this one, do this one, read this data, execute. And you come back with errors. You correct. For months, you'll be going back and forth. Between 1984 and 1990, while in Lagos State University, I'm still there, we write long codes in MS-DOS. Long codes. But these codes are based on statistical formula. So we have to know the formula. And then write the codes. And I use my Amstrad PC. Oh, wonderful. I carry memories of my Amstrad PC, which I bought in 1985. And I happen to be one of the very early persons who owned PCs in the university. By 1991, I was visiting professor at Curtin University of Technology in Perth, Western Australia, one of the leading universities of technologies in the world. And I taught advanced statistics too. So there, I was using rudimentary software, all based on all these statistical tools and processes. By 1992, 1995, I was appointed consultant data analyst to UNICEF. Then I wrote long strings of codes for all my data analysis. So I have to know the formula, write codes and codes and codes and programs and programs and programs. UNESCO engaged me as consultant data analyst, and also hours of coding, days of coding. The federal government of Nigeria asked that I should be consultant data analyst for the education sector analysis project. But from 2006, we started using state-of-the-art statistical software. So why have I gone into all of this? Not for boastful reason, but to let you know that you are now in a world of no scary formula. All you need to know will just be the mathematical model, then when to use it and how to use it. And then when the computer has analyzed, leave the rest to the computer to analyze for you, the IBM SPSS and others. After the analysis, all you then need to do is interpret and report your results. Now, come with me. God keep us to 2050. Let me tell you what the world will look like. World of advanced statistics. You all will get your PhDs in 2020, 2021, 2022, thereabouts, and then you are teaching universities. Let me tell you what's going to happen in the future. The computer will do everything for you from start to finish because artificial intelligence will have kicked in. So you tell the computer, oh, I want to collect data on this. The computer will do that for you, do your sampling, do everything for you. Now, say at that time, the Internet of Things will pervade the world and you don't have any challenge to reach your supervisor, to collect your sample, to write to the journal editor. Everything would be seamless. So, ladies and gentlemen, dear students, we are preparing you in this course for that world of tomorrow. Remember, I went back in history, not for boastful enterprise, but to let you see what the progression has been. So, any professor who says he or she is teaching you statistics, to a mixed group like you, you are people in administration, in law, in STEM education, high state education, mixed group, and wants to be now scaring you with formula, you have to run for that person because it's taking you back to the scary old days. But in this course, we are going to be learning a few formulae, about 10 of them throughout the course. Why do I want to do that? I want to do that to let you have a feel of how the computer or the software is slaving for you and sweating at the background. Look at it. The computer is doing the work for you, and comes with an output. So if you are not able to have a feel of what the computer is doing, you will not be able to appreciate the statistic as well as technology that has developed so far. Now, back to business. Which business? That's business of how you compute mean, standard deviation, and variance. I told you that these are three important bridges between inferential and descriptive statistics. What are the reasons? I have two reasons. One is that all the studies you'll be conducting, all the quantitative studies that you'll be conducting, will all be concerned with finding variations in individuals and groups. And I tell you what, all the formulae that I'll be using in this course for computing sample statistics will depend one way or the other on mean, standard deviation, and variance. Oh, knock. Who is knocking? Mr. Mean is knocking. Come in, man, come in. So here comes Mr. Mean. Mr. Mean has a familiar name, average. What's the average of your scores? That's a familiar name. But that's a symbol. This symbol, you can see this X with a bar on top of it, like a cap. He's wearing a cap, X bar. But why is it X bar? You know the reason? Of course, because the mathematicians, the statisticians have told us that this is what they want for their symbol as mean. How do you calculate it? You add up all the numbers. You know this thing. That's why this is going to be short. You add up all the numbers, then you divide by how many numbers there are. Now, let's take an example from our class data. I told you, no theory in this course. We have collected data. We are going to be analyzing it so it becomes relevant and appropriate for our use. Yeah, so these are data from where we want to get some materials for computing the mean, because Mr. Mean is here. So let us look. Maybe we'll take on this. What did you score in discussion forum 1? And then we can find the average or the mean. For our class, we're not going to be using average. Average is too commonplace, so we use the word mean. Yeah, so we want to find the mean of this. To make the thing a little bit more exciting, we're just going to take about 10. Can take Okebukola or Deke, just take 10 people from here. And so in doing that, I've been able to extract, let's say, here. So we now have Okebukola or Deke here, Daishimiye, and all of that. So I've taken this 10. Let's take this 10. I want to compute the average of the scores for this group. Sorry, I used the word average, I mean. Okay, so here we go. I've taken the scores here. I've just copied and pasted here. So for mean, only 2 steps. What are the 2 steps? You add the scores all up, add this, and then divide by the number of scores. There are 10, 1, 2, 3, 4, 5, 6. Then let's add this up. Some of you will be grabbing calculator. But let's see, this 10, 25, 32, 38, 58, 66, 70, that's 83. So this is 83. We have added them all up and we will get it 83. You can see I've added this. These statisticians have come again. They say, well, let us have a symbol which will summarize or which will represent, summation. So they've come with this symbol, sigma. It's a Greek letter. I think one of the letters of in the Greek alphabet is called sigma. So we have added everything up here. So I'm going to put the sigma here. So let me put it on the right. So this is sigma. I've added everything. So that's step 1. Step 2 is divide by number of scores. So divide this by that, and that gives us what? No use calculator. Divide 83 by 10 is 8.3. So we'll have it like this, 8.3. That's our mean. Let's move this one here. So the mean is 8.3. So simple as that. Mr. Mean, we have taken care of you by adding the scores and dividing by number of scores. And we have used data, not fictitious data. These are data live from our class. Knock, 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 knock. Oh, who is knocking again? I thought Mr. Mean would have dealt with you. Oh, it's another person, Mr. Standard Deviation. Okay, come in, Mr. Standard Deviation. Let us now look at an example from our class data to see how we compute standard deviation. That's our objective number 2 in this lesson. So let's use the same data that we used for finding the mean. So this is the data. I will find the mean to be 8.3. What we want to do now to find the standard deviation. There are 4 steps. You note that in the average, when we're finding the mean, we have 2 steps. Now we have 4 steps. Step number 1 is for us to find the mean, which we have done. Step number 2 is for us to find out the deviation from the mean. That means subtract the mean from each of the numbers. But why is this so? What is this meaning? What does this standard deviation thing mean? Now let's look at this data here. We'll find that the mean is 8.3. So look at Ademola. Ademola is on the left of 8.3. That's 5 minus 8.3. Odekeye is on the right. That's 8.3 minus. You can see they are scattered. They are deviating from the mean. This is closest to the mean, 8, followed by this, but this one is positively deviating to the right. This one is negatively deviating. This one is negatively deviating. This one is negatively deviating. So what we want to do is to find how these scores are scattered along when compared with the mean, how they are scattered, and then try to find what standard way are they deviating. That's just the meaning. I want to see, this statistics, we're looking at the variability, how the scores are varied. And so we'll go back to our standard deviation. We said the first step is to get the mean, which we have done, as I said. They subtract the mean for each of these. So these are the means. Let me make this bolder. Yes. So we have the mean here, 8.3. So we want to see how they deviate. Now let's put the mean here. So the next thing to do is to subtract this from this. That is x minus x bar. So let's go here. Let's find the deviation of each score from the mean. So how do? We do it like this. X, this one, minus x bar. So that is 5 minus 8.3. 5 minus 8.3 is minus 3.3. 10 minus 8.3 is 1.7. So we'll do for the rest. I've done for the rest here, and you will see what I got. So this is what I got. Deviation from the mean, x minus x bar. So these are the deviations. You can see how some positive, some negative, some positive, some negative. By the way, if you add this all up, what do you think it will come to? Let's see. I'm telling you to come to 0. You can see 0. What you see, you want to find out the standard deviation. So the next thing, by the steps that we have put in there, is to now square this deviation scores. That's step number 3. So let's get on to it. By the way, I'm now representing this x minus x bar by this small x. This x minus x bar, the grammar too much. So let's use this small x. But when I get back to the formula, you see that I still present this. So by small x, it can be anything, by the way. So we have this as the x minus x bar. That's the deviation from the mean. As I said, we're going to square this. When we square this is what we get. If you square minus 3.3, that's 3.3 times 3 minus 3.3, you get this. 1.7 times 1.7, you get this. So the purpose of squaring is to just eliminate this zero thing. So at the negative sign. So we then end up getting 34.1. We have to add up. That's the next thing to do is to add up. So this is the adding up of this one. You can see how easy standard deviation is. First thing, find the mean. Second thing, find how they are deviating from the mean, the deviation. You know you are doing standard deviation. Next thing, you square. And the next thing, you add. Just add them all up. Then you find the mean of this one. In other words, there are 10 students here from Ademola, Odeke, Fiaker, Jashimiye, Hilaire, and all that to Akitayo. There are 10 students here. So you find the average. That's 34.1 divided by 10. Oh, but it's not so easy. Not like that. Not like that. Because, for example, you know, we took our data from, let me just get back to it. We took our data from these 44 people. So we're just extracting a sample from them. So had it been that we took all of this as a population, we can just stick with that 10. But because sample, we have to subtract 1 from it. So total number minus 1. So you want to ask me why it is n minus 1? Here, use n minus 1 to divide. It's because the statisticians told us so. Now, so 34.1 divided by 9. You know, 10 minus 1 is 9. That has given us 3.788. The last step to get standard deviation, last step, is to take the square root of that, and we are done. I told you it's simple. So you take the square root of 3.788, and what do you get? You get 1.946. You can see I've walked from the problem, the steps, to the formula. So what's the formula of standard deviation? The square root of summing up all these deviations squared over n minus 1. Or, you know, I represented this one by small x. So it's sum small x squared over n minus 1. That is how we calculate standard deviation. To let you know the thing again, very simple steps. Actually, this table is the heart of the matter. So you get the scores, you find the mean, you find the deviation from the mean, and then you square each of this, and add them up. After adding up, you then divide by the total number of students here minus 1, and then you find the square root. Easy does it. Knock again. Who is knocking again? Oh, Mr. Variance. Oh, you are the third person. The 3 bridge thing we're talking about. Wonderful. Welcome, welcome. So let us compute a variance from our class data. Calculating the variance is the easiest of them all, because variance is, I've just labeled it a cousin of standard deviation, because if you square standard deviation, you get variance. That is, variance, if you know standard deviation, just square it. For instance, the standard deviation of the data that you have from our class is 1.946. So the variance is the square of this, and it gives us this. That's the variance, which is as easy as can be. So in summarizing, we set out in this lesson 3 to find the mean, standard deviation, and variance. So we extracted 10 students, and then Ademola, Deke up to Akitayo, we had all these courses. So there are 10 of them. So our n stands for the number of students, or the number in your sample is 10. The mean that we calculated, 83 divided by 10, 8.3. The standard deviation, 1.946. Square standard deviation will give us the variance. This is a 3.788. You can see I'm putting this as 3 decimal place, but that's not on. It has to be just 1.94 or 1.95 or 3.79. But you'll see what I mean in a minute, because we now want to find out whether our calculations are correct. How do we know? We have to pay a visit to Mr. IBM SPSS. So I have IBM SPSS Statistics version 23 loading now, and it comes up with here. So it's giving me data view, variable view is open. What can I do for you? Yes, what you can do for us in this class is to help us find the mean, standard deviation, and variance of the scores. Let's look for the scores. Yeah, so these are our scores. We'll just take these ones from here. Let's see. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm copying this and I'm transferring straight on to SPSS. I paste it here. Yeah, so we have these are scores. We're trying to find out whether all the things we do with our calculator are correct. So we go to analyze, go to descriptive statistics. Let's go to descriptives. This variable, I put it here. That's actually the score and discussion forum. We look at the options. We want the mean, we want the standard deviation, we also want the variance. Let's go, man. Yeah, so here we go. So it has told us that our n is 10. Are we correct? Let's check. Let's check. Yeah, okay, let me put a slideshow from here. So our n is 10, so we're correct. And it's telling us that our mean is 8.3. Let's go back to here. It's telling us that our mean, where's our mean, is 8.3. So we're correct. It's telling us that, okay, let me move this here. Yeah. So standard deviation is 1.94651. 1.946. Bravo! And it's now telling us that variance is 3.788. It's telling us that variance is 3.789 because it's condensing the other figures after here. So bravo, we have done very well. But the moral of this story, dear students, is that for how long we will be calculating? Look at the long list of students that we have in the class. Assume you have 1,000, 2,000 students. Are you going to be calculating with them? That is why we're advising that just learn the fundamental principles, the mathematical model, and learn how to use it. The computer is there for us to use for doing these statistical tasks. So lesson is over, but what have we learned? We learned how to calculate the mean, standard deviation, and variance. Oh, there's an assignment for you. During the class, I computed for 10 students using discuss or the discussion forum. So what I expect that you should do is for the class data, compute the mean, standard deviation, and variance of the scores of any 20 students on quiz number 1. Next lesson, that's lesson 4, we'll be learning how to use the t-test. We find the t-test quite interesting in data analysis. From me, Peter Okebukola, is bye. My email ID remains this. Bye-bye for now.